I reckon we should go and have a look at the biggest optical telescope in Western Australia. And that happens to be the Zadko Telescope. That's a 1 metre research grade telescope here at the GDC precinct. So I tell you what, let's go and have a look this way. The Zadko Telescope is operated by the University of Western Australia,
furthering our understanding of the universe.
Pretty deep words. I think we should go and actually have a look at the telescope. Before we do, let's just check out the building. This is the building here. Now this is a rather odd design. It's not your classic observatory design like what they have over there in Falcon. Okay, this is what's called a roll-off roof observatory, which essentially the roof, which is that big structure there, rolls off along these rails and gets it out of the way. It exposes the telescope to the elements, but also it gives us uninterrupted views, and you don't have to worry about having the dome spinning around to do anything crazy like that. You're probably thinking, what on earth would happen if it starts to rain or it clouds over? Does the telescope get washed out? No, it doesn't. They've got this fantastic thing called a weather sensor. That is that thing up here. So the weather sensor there tells us when it's cloudy, when it's going to rain, tells us wind speed, wind direction, and it's got a security camera there as well. I think we should go and have a look. Let's go and have a look at the control room, where the heart and soul, well, not so much the heart and soul, but where the brains are of the telescope. Here we go, get keys. One of these ones. This one, maybe. This is the control room for Zadko. It's where all the computers are kept. It's very dull and uninspiring. It does show you the modern observatory. Gone are the days where an astronomer sits behind the telescope. Anyway, let's go and have a look at the telescope through this door. Oh, it's in darkness. Let there be light. And there was. Here it is. This is the Zadko Telescope. What a wonderful machine. It's very yellow. Made by a company called DFM Engineering from the United States in Colorado. What is it with Colorado and astronomy and people from Colorado coming to the GDC? This is built in Colorado. The Falcon telescope comes from Colorado. One of our new employees, he's from Colorado too. And I met a bunch of Americans the other night. They were from Colorado as well. Must be something about Colorado and astronomy. Anyway, so this telescope here is a 1 metre class research grade telescope. It's on a forked equatorial mount. I said forked, okay, so get your mind out of the gutter. Just remember how I told you that astronomers don't look through eyepieces anymore? This it's been replaced by these things here. This is called a CCD camera. CCD stands for Charged Coupled Device. So gone are the days where they do this and go, oh look, very interesting. No, it doesn't happen. So this is just a big digital camera, very, very sensitive, and it records all the data and stores it on a computer for referencing and for analysis. So this collects all the data and sends it to the control room where it's kept in a database. So if any researchers from University of Western Australia or even abroad use this occasionally, they can easily get all their information, all their data from across the net, which is very, very, very handy. Big news in the scientific field and also in the general community, which got a lot of people excited, is the detection of gravitational waves from a merging neutron star source. The gravitational wave, I'm just trying to remember the name of the number, is GW170817. Try and say that past 5 times. No, I'm not going to. Originated from a galaxy called NGC 4993 in the constellation of Hydra, about 130 million light years away. Okay, so this was important because what happened was August 17th, the LIGO detectors in Hanford and Livingston, and also the Fermi Gamma Ray Explorer, which is a satellite up in orbit, detected energies at the same time from the same spot. This set into motion about 70 telescopes worldwide to slew into action. Of course, Zadko was one of them. And in fact, Zadko provided some amazing data to contribute to the study of this neutron star merger. What is a neutron star? I'm glad you asked. A neutron star is a very, very dense stellar remnant. So after a star, many times the mass of our sun, it exploded in a supernova event, and what remains is a very dense ball, something about the size of Rottnest, but weighs in at a couple of solar masses. This marshmallow here we go, marshmallow. If this was neutron star material, this would weigh the same as Mount Everest. Neutron star. Oh, sit in your stomach like that. Two of these were spinning around each other and eventually smashed into one another. As it did, cataclysmic explosion. Gamma rays, X-rays, a whole bunch of different light came out, and gravitational waves, ripples in the very fabric of space-time. It also showed us the production of gold and platinum and selenium, these heavy metals that weren't really sure about where their origin came from. It wasn't really from a supernova event or through thermonuclear fusion. So it's been a bit of a puzzle, but this is now confirmed where they come from. So things like this gold here originated from a neutron star. Terribly exciting time. Detection of two neutron stars spinning around each other, smashing into one another, generating this intense pulse of radiation, which is what Zadko saw, but also the gravitational wave detectors detected the ripples in the fabric of space-time. So what an absolute awesome piece of science, with telescopes like Zadko and a whole bunch of telescopes all around the world, and also the gravitational wave detection. So gravitational wave astronomy is really making tracks. So keep an eye out from that. That's all for this week. I apologize again for being so late in my vlogs, but you know what? Hopefully same time again next week. So until then, clear skies and hail Sagan. Catch you later. Neutron star. Nice.